This lesson is going to be looking at solving one-step equations. When you have an equation, remember the goal is to isolate the variable, and isolate means to get the variable by itself because we want it to be whatever that variable equals. So let's first take a look at what a solution is. A solution is a value that produces a true statement when substituted in for the variable. So if I'm looking at the one-step equation, x plus 9 equals 15, I want to know, is x equals 5 a solution? I can take my value of x, which is 5, and instead of putting x plus 9 equals 15, I can substitute the value of x with what I think it is. I think it's 5, so I could say 5 plus 9 equals 15. So I can evaluate what's left on this left-hand side. 5 plus 9, that's 14. 14 does not equal 15. Since they're not equal, that's false. Then is it a solution? No, it is not a solution. Let's take a look at the other example. If I'm looking at x plus 9 equals negative 15, I think that x is 6. I want to put 6 into the equation. So I want to say that 6 plus 9 equals negative 15. 6 plus 9 is 15, but 15 does not equal negative 15. So again, that's false, so that is not a solution. In order for it to be true, it would have to be the same number on each side at the end, and that would make it a solution. But since both of these statements are false, both of them are not solutions to the particular equation. So let's take a look at how to solve equations. Equations are all about opposites. And remember that property of equality. What you do to one side, you have to do to the other side. So if we're looking at this, I want to look at solving my equation. So I'm going to draw a pretend line, this line really isn't there, down the middle of my problem, which is where the equal sign is. So I need to isolate my variable. What's on the same side of the equation as my variable, or the same side of the line as my variable? It should be the plus 3. The only way to get rid of plus 3 is by doing its opposite. So the opposite of plus 3 is minus 3. So I want to subtract 3 from both sides, or my equation, or both sides of that line. So 3 minus 3 is 0, so those two 3's cancel each other out, and I'm left with x. I still have my equal sign, and then 17 minus 3 gives me 14. So my solution is that x equals 14. Now, some of this you will be asked to justify using those properties that we came up with yesterday. So looking at the properties of real numbers, which property lets us take away something from both sides and have it still remain equal? My justification for that step of solving the equation should be the subtraction, because we subtracted, property of equality, and then we have to give a reason for why we did it. We did it to isolate the variable, and then our x equals 14 is our solution. Let's take a look at this one. If I have x minus 2 equals 9, I have my imaginary line again, and if I want to do the opposite of what is there to get rid of the minus 2, I would have to add 2 to both sides. So minus 2 plus 2 cancel each other out because that's 0. I'm left with x, and then 9 plus 2 is 11. So this time, if I was going to justify this, you don't have to justify every time, only when it specifically asks you to, but if we were going to justify this step of this equation, I did not subtract this time, so it's not the subtraction property. I added, so this would be the addition property of equality. And we're doing it to isolate the variable. And in this part here, the x equals 11 is your solution. Let's look at this one. This equation, I have my line again, and I want to assume that when a number and a variable are next to each other like that, that means multiplication. So in order to get rid of the 2 that's with the x, I need to do the opposite of multiplication, which is division. In algebra, we set up division like that, so it looks like a fraction line. We do not use this symbol. And then we have to divide by the number we want to get rid of, in this case, which is the 2. So the 2's cancel each other out. I'm left with the x. I have my equal sign still, and then 10 divided by 2 is 5. So the property that let me do this, if I was going to justify this equation, is the division property of equality. And we did it to isolate the variable. And then the x equals 5 is our solution. The next and last example equation, if I had my imaginary line, I have to get rid of the 6. Right now, the x is being divided by the 6. So the opposite of division is multiplication. In algebra, we do not use the x as a multiplication symbol because we already have an x in the problem. It's a variable. So it's going to get us confused of what we're counting as an x and what we're counting as a multiplication symbol. So in order to multiply this, I need to set both sides up using the algebra symbol for multiplication, which is the parentheses. And I want to multiply both sides by what I want to get rid of. So I want to get rid of the 6. So then these two 6's on the left cancel out. I'm left with x. I have my equal sign still. And then on the right, I have 4 times 6, which is 24. So this time, I use the multiplication property of equality. And we did it to, again, isolate the variable. And then the x equals 24 is our solution.